Welcome back to Join Mathematics, a platform where we establish understanding in mathematics. We are on our series of topics on vectors. Now we want to consider the vector components in terms of unit vectors. Now we are familiar with, let's say, a component of R in terms of column vector xy. So we can say that we have a vector, let's say A 1 3, or a vector, a position vector OB, which can be written as, let's say, 2 4. Now these are column vectors. What we want to write them in terms of unit vectors. So we have a Cartesian plane, the x-axis and the y-axis. Now the term unit vectors, what does it mean? Unit vectors means a unit on the x-axis and a unit on the y-axis. So the unit on the y-axis is termed J component, and the unit on the x-axis is termed I component. So if I want to write the component of A 1 3, or let's begin with xy, and I call this R. This is in column vector, and I can separate this in terms of unit vectors, as this will become x 1 0 plus y 0 1. Now this brings us back to scalar multiplication, because when we do this operation here, it will result into this. Now 1 0 is the unit vector represented on the x-axis, so I will call this I 1 0, and y is the unit vector represented on the z on the y-axis, so I'll call I column vector to be 0 1. So I can rewrite it here, that's j column vector 0 1, and the I column vector is equals to 1 0. So with that done, I can rewrite my R, so make the substitution of the column vector of 1 0 is equals to I, and the column vector of 0 1, okay, is equals to j plus yj. Therefore I can rewrite this to be xi plus yj R. So we can come to a conclusion that if R is equals to xy, okay, if R is equals to xy, a column vector, it can be written in terms of unit vectors. That's R, okay, is equals to xi plus yj. So let's take examples here. So I have A in terms of column vector of 1 2. I can rewrite this to give me 1i plus 2j, okay, and B, I can write B as a vector, column vector, to give, let's say, 2 3, and this will be 2i plus 3j. Now this is how we convert the column vector to unit vectors, to vector components in terms of unit vectors. So let's take, for instance, I was given a position vector of 1 minus 1, and likewise a position vector of, let's say, 3 minus 4, and also a position vector OP of minus 7 and 9. Now you can pause the video right away and see how you can convert these column vectors to component vectors in terms of unit vectors. So pause the video now and give it a try. And move. So this, following the principle that we have here, that if R is equals to column vector xy is equals to xi plus yj. So therefore this is our x here and this is our y here. So therefore this will result into 1i plus my y minus 1j, and this will result into I minus j. Similar here, this is our x and our y is minus 4. So this will result into 3i plus minus 4j, and this will be equals into 3i minus 4j. Same thing applies there. Minus 7 is our x, 9 is the y, so this will become minus 7i plus 9j. So this is how we convert the column vector to vector components in terms of unit vector. Now in our next lesson, we will see something entirely different when we talk about vectors in space. We have been familiar with saying r is equals to x, y. Okay, that's two components. Okay, that's in the x-axis and y-axis. So this in terms of unit vector is I, in terms of unit vector is j. Now what if we have a vector in space that has three components, x, y, and z? So this is that of x-axis, this in terms of y-axis, and this in terms of z-axis. So we know that this is I, we know that this is j, and we'll be looking at what this component is, k.